tests. So a cumulative probability density function models the probability that a random variable will take a value less than or equal to X. So sometimes it's like the chance of 3 or less wins, or 5 or more. So it's a tail of events. So here's an example. P of X is less than or equal to 2, which of course would be loads of stuff added up. Okay, so you could work them all out separately using the PD function or the formula, but actually a lot of you are familiar with the CD function on the calculator, which will just find all of them added up. So, or on a statistical table at the back of in the formula book in the exam, that's useful as well. So if you're happy using that, hopefully we are, let's try this question now. Here we go. So a few things to consider. So a carnival game involves drawing a token from a box. There are 20 tokens in total, 1 gold, 2 silver, 4 bronze, which win a respectively win a prize. Jess plays the game 8 times to try to win the prize. That's important as well. It's very easy to mess up what N is for this question. Calculate the probability that she wins at least 2 gold prizes, between 3 and 6 inclusive prizes that aren't gold. Okay, I'm actually going to give you 3 minutes to attempt this. Set it up properly as a binomial, use your calculator, and see how we go. I think this is a really good one to practice. Brilliant. Here we go. Give it a go. So really look out for what N is, how many times she's playing the game. All the other stuff sort of informs us for the probability. So be really careful setting this up. We'll check in a couple of minutes, see how we go. Well done. Okay, so quite a lot of information to take in. Let's give it a try. So let's see how we go. Okay. So to start with, we're going to determine the variables for the binomial. So we need to basically, for the first part, work out the probability of more than 2 of the 8 being gold. Okay, so 8 tokens are being taken out of the box. This means that the number of trials n is 8. So there's 20 possible tokens and only one is gold. So the probability is 0.05. The only way that this fits binomial is if you put it back in and it's the same probability every time. And that's what we're doing. So the chance of success is a 20th each time that you pull out the gold counter. Okay, so that's P, that's the probability of success. Now, we need at least 2 tokens to be gold. Okay, so what that means is we actually want 2 or more. So that would be great if you got 2 gold tokens, or 3 or 4 or 5 or 6 or 7 or 8. 2 or more will be what we want. Okay, so this is a tail of events. This is actually an upper tail of events. So to correctly calculate this on your calculator, greater than or equal to 2, some of you will have a calculator that can do that. But if your calculator only does binomial cumulative from below, you will have to do this method where you do 1 minus the probability of less than 2. So basically 1 minus less than or equal to 1. But if you've got a calculator that does the binomial upper tail, which I think the CG50 does, that's a real advantage. But because this was an upper tail, if you haven't got that, you'll have to minus 1 minus the lower tail, rather. So just make sure you've done it the right way round. It still should be quite a low probability. So like do sense check that value. Well done if you got it. Right, so just to be clear, because for the normal distribution, we can be a little bit sloppy with the notation. The strictness of the inequality is actually imperative for this kind of question. So this said, the wording of the question, if we look back, implied it had to be greater or equal to 2. At least 2 gold prizes means 2 or more. So that's greater than or equal to 2. If you put a strict inequality, you're doing the same as greater than or equal to 3. So because you wanted to include 2, this is really important for the binomial. The binomial, the inequality matters. For the normal distribution, doesn't matter as much because it's cumulative. Because it's continuous. So this one, yes, this is really important that we get the strictness of that inequality right. And obviously it will change the answer. So for part 2 of the question, we want to determine the variables for the binomial distribution. So we need to determine the probability of between 3 and 6 tokens being bronze or silver. So there's 8 tokens, so n is still 8. 20 possible tokens, 2 are silver, 4 are bronze. So actually there's 6 20ths of a chance that we get a bronze or a silver, which is 0.3. 30% of the time on any given go, that will happen. So that's our binomial. It will be n as 8, p as 0.3. And we want between 3 and 6, inclusive. So again, some of you have a calculator that can cope with that. But if not, what we can do is look at how we could split these tails up. So this is what we're doing. Between 3 and 6. So you could do this as the probability of less than or equal to 6 minus the probability of less than or equal to 2. And that will leave 3, 4, 5, 6, like everything in between. That will give us our answer.